So one extra wrinkle here, we talked about these are the orbitals that electrons can occupy, but there's one weird effect of electrons that comes out of sort of the symmetry of space-time, and that is electrons can have another quantum number called spin. An electron can be either spin up or spin down. So each orbitals can have a maximum of 2 electrons. However, the 2 electrons in the same orbital must have opposite spins. They cannot have the same spin. There's this deep fundamental theory about quantum mechanics which says that no 2 electrons can have the same 2 quantum numbers. If they're in the same orbital, they have the same quantum number. They have the same n, the same l, the same ml. They have to have a different spin, or else they simply couldn't be there. They would literally not fit. They cancel each other out. So yeah, opposite spin quantum numbers. What is spin up and spin down? That's actually arbitrary as well. Like, does nature care if you're standing on your head or not? But they're spin in 2 opposite directions. And it's important to remember that spin is not really quite the same thing as a top spinning around. It's related to angular momentum. It is a type of angular momentum, but the electron is not literally spinning around because it's a wave, first of all. So what it is basically electrons have this extra packet of angular momentum that they carry around themselves, in addition to the angular momentum they have from moving around the atom. So they each have this little bit of angular momentum, and it can go in one of 2 directions. Yeah, so the Pauli exclusion principle, no 2 electrons can have the same 4 quantum numbers. Actually, in general, they can't have the same quantum numbers in any situation. But if they're around a hydrogen atom, then you have 4 quantum numbers. Yeah, so usually we assign the value 1/2 and -1/2. That's sort of arbitrary as well. But it's, you know, plus 1/2 and -1/2. Yeah, so -1/2 of plus 1/2. There's actually spins with the nucleus as well, but we won't get into that. That starts getting into how does an NMR machine work. We won't get into that. But for now, it's enough to remember, and the spin will become more important later because it affects how atoms react to magnetic fields. But for now, we just need to remember that you can have 2 different spins, and therefore each orbital can have up to 2 electrons in it that have opposite spin. This has nothing to do with the phase of the wave function. It's a different label entirely. Yeah. Okay, so knowing this, what's the maximum number of electrons in orbitals with the following quantum numbers? Here we're just practicing to make sure we can get these right. N equals 3, L equals 1. Okay, well, let's see. L equals 1. This is it's a p orbital, and so these are the 3 p orbitals, and there's 3 of them, ml, -1, 0, and 1, and so there's a total of 3 times 2 electrons per orbital, 6 electrons. There can be up to 6 electrons in 3p orbitals. N equals 2, L equals 2. Aha! Trick question. The answer is 0. No electrons can be in orbitals like that because those are not possible quantum numbers. So I guess you'd say, how many maximum number of electrons? None. There's no such thing. N equals 4, L equals 3. So let's see. 2 is D, 3 is F, actually. So these are 4F orbitals. And so 2 times 7 would be 14 electrons that can fit into 4F orbitals. Okay. 4F orbitals. Now think, if you look at the actinides and lanthanides, how many are there? There's 14 of them. We'll get into the connection between F orbitals and those later.